This lesson looks at a different way to graph parabolas than what we've done before. We're just looking at a new approach. This time we're going to look at finding the x-intercepts. So we've done y-intercepts before. That's when x is 0. But the x-intercepts are when y is 0. So we're going to plug in 0. And then from here, we are going to solve this equation. And we are going to solve it by factoring. So I'm going to go straight to my two parentheses. I need two numbers that multiply to -3 and add to -2, which would be -3 and 1. So when I solve, I get x is 3 and -1. That makes my x-intercepts 3, 0, and -1, 0. So I can graph those 2 points. Okay, and now I'm going to find the vertex. Now, to find the vertex, I can do the opposite of b over 2a like we've done before. Or, new fact, the vertex has to be in the exact middle of my two x-intercepts. So the exact middle would be here at 1. Now, because this starts with a positive x squared, I know it's opening up, so my vertex has got to be somewhere down below here. So let's see if that happens. So I'm going to put in 1. That's going to give me 1 minus 2 minus 3. So that gives me -1 minus 3, which is -4. So my vertex is 1, -4. And now I can graph my parabola. What's new this time, or it's not new, but we've never done it with the parabolas, is identifying the positive and negative intervals. So positive intervals are everything that's above the x-axis. Negative intervals are everything that's above. So in this graph, I have this positive interval and this positive interval, and below I have this 1. Now, when we do these intervals, we are going to write them in as inequalities, not in interval notation. So this one here on the left, it starts at -1. It's all the numbers to the left of -1, which means that it's getting smaller. So we can say x is less than -1. Over here, this interval starts at 3, and it's all the numbers to the right, or all the x values to the right. So x is all the numbers greater than 3. Finally, for the negative interval, it is everything in between -1 and 3. Because remember, when we read positive and negative intervals, we read it off of the x-axis. So it's everything in between -1 and 3. And we write it as a compound inequality with less than symbols, smaller number on the left and bigger number on the right. Okay, try this again. Number 2. So to find the x-intercepts, I'm going to plug in 0 for x. So I get 0 for y. So I get 0 equals x squared minus 4x plus 3. Now I'm going to factor it. The two numbers that multiply to +3 and add to -4 would be -1 and -3. So when I solve, x equals +1 and +3. So my x-intercepts are 1, 0 and 3, 0. So I can graph those 2 points. So now to find the vertex, I can do the opposite of b over 2a, or I know that it's got to be in the middle. Well, the middle would be 2. So I'm going to plug in 2 and then simplify. So this is 4 minus 8 plus 3. So this is -4 plus 3, which is -1. So my vertex is 2, -1, and there is my parabola. Intervals. Positive intervals is everything that's above the x-axis, negative is below. So this section over here is below, and it starts at 1 and is everything to the left, so it's everything less than 1. And then over here, this starts at 3 and it's everything to the right, so it's everything greater than 3. The only negative interval is down here, and it's all the numbers in between 1 and 3. And again, remember the compound inequality has to be less than symbols, smaller number on the left, bigger number on the right. Okay, let's look at number 3. Number 3, this starts with a negative, so we know this one's going to be opening down. First, same thing though, got to find the x-intercepts. So we're going to plug in 0 for y, but to be able to factor this, I cannot factor it with the leading coefficient negative, so I have to take out a -1. When I do that, I'm dividing each term by -1, so that leaves me with a positive x squared, and then +9 divided by -1 is -9. So when I factor it, the negative 1 stays there. This is the difference of squares, and I take the square root of each one. The square root of x squared is x. Square root is 9 is 3. 1's a plus, 1's a minus. So when I solve, x equals negative 3 and positive 3. So my x-intercepts are negative 3, 0, and 3, 0. So then when I go to graph those, here are my 2 points. All right. Now I need to find the vertex. Well, I can do the opposite of b over 2a, or I can recognize that 0 would have to be in the middle, so it's going to be 0 something. So to figure out what y equals, I'd have negative 0 squared plus 9, which would just be 9. And when I plot this point and connect the dots, my graph definitely opens down. Okay, but now that my graph is opening down, my positive and negative intervals, it's a little bit different. This time, there's only one positive interval. There's only one section above the x-axis, and that is all the numbers in between negative 3 and 3. So I'm going to write it as a compound inequality. Then I have to talk about my 2 negative intervals. Well, there's a negative interval here, which is everything to the left of negative 3, so it's everything smaller than negative 3. And over here, it starts at 3 and it's everything bigger, so it's x is greater than 3. All right, try it again on the last one. So first, to find the x-intercepts, I'm going to plug in 0 for y, and then I need to solve it by factoring. Again, I can't factor it with a leading coefficient negative, so I'm going to take out the negative 1, and that is essentially dividing every term by negative 1, which changes the sign. So I have positive x squared minus 2x minus 8. So when I factor this, two numbers that multiply to negative 8 and add to negative 2 would be negative 4 and 2. So when I solve, this negative 1 does not give me a solution. The first parentheses gives me 4, 0, and the next parentheses gives me negative 2, 0. So I'm going to graph them. Okay, now to find the vertex. Well, it's got to be in the middle. If you're not sure, you can just count over. It's got to be at 1. Or, again, you can always do the opposite of b over 2a. That doesn't stop working. All right, so then we're going to plug in 1. So we have negative, and then the 1 squared, plus 2 times 1, plus 8. Now, don't make a mistake on this one. You're just squaring positive 1, which is 1, and then adding the negative. So I get negative 1 plus 2 plus 8. So negative 1 plus 10, which is 9. So my vertex is 1, 9. And here's my parabola. Okay, positive interval is everything that's above the x-axis, and we read it off the x-axis. So it goes from negative 2 to 4, and when it's a compound inequality, you put the x in the middle, smaller number on the left, bigger number on the right. This is a negative interval, and it starts at negative 2, and it's everything to the left, so its x is less than negative 2. This is negative, it starts at x, and it's everything greater than 4. All right, we're going to do the same thing without doing the full graph, but this time it only wants the positive intervals. Well, to figure out the intervals, you really need to know these x-intercepts. That's what's going to determine it. So we're going to have to calculate them first. So in this one, I plug in 0, and I'm just going to go straight to factoring because I know that's what I'm going to have to do. It's a trinomial with the leading coefficient of 1. So I need two numbers that multiply to negative 21 and add to negative 4, which would be negative 7 and 3. So when I solve, x equals 7 and negative 3. Now when I think about graphing it, this starts with a positive 1, so it's going to open up. It's going to cross the x-axis somewhere, and those 2 points are at negative 3 and 7. So if this is kind of a sketch of my picture, I'm going to have 2 positive intervals. Okay, one is going to be everything less than negative 3, and the other is going to be everything greater than 7. Okay, let's see what happens over here. Plug in 0. I cannot factor this with the leading coefficient negative, but this time there's more than a negative 1 I can take out. I can actually take out negative 2. So when I do that, I just get x squared, but 18 divided by negative 2 is negative 9x. Negative 40 divided by negative 2 is positive 20. Now I need two numbers that multiply to positive 20 and add to negative 9, which would be negative 4 and 5. So when I solve, I get x equals 4 and 5. Now this graph, because it starts with a negative, it's opening down. And at some point, it's going to cross the x-axis at 4 and 5. So the only thing that is positive is this part up here. So we say 4 is less than x, which is less than 5. And the next one, I'm going to plug in 0. It's a binomial, and there's minus sign. I can take the square root of both, so I'm going to go straight to my two parentheses. The square root of x squared is x. The square root of 25 is 5. One's positive, one's negative. So I get negative 5 and positive 5. This one, because it starts with a positive, it opens up. It's going to cross the x-axis somewhere at negative 5 and 5. So where it's positive are these two places. So where x is less than negative 5 and where x is greater than positive 5. On the last one, plug in 0. I cannot factor with that leading coefficient negative. So I'm going to take out negative 2, leave me with x squared. 4 divided by negative 2 is negative 2x. 16 divided by negative 2 is negative 8. Now I need two numbers that multiply to negative 8 and add to negative 4. I said that again wrong. Negative 2, so it'd be negative 4 and positive 2. So when I solve, x equals 4 and negative 2. Now this one's going to open down. It's going to cross, and I knew that because it was negative. It's going to cross the x-axis at 4 and negative 2. The only place it's positive is up here. Oh, I did that backwards. All right. This should be negative 2 and 4. So the only place it's positive is up there, which is in between negative 2 and 4. Now I do want to show you one more factoring one that's going to be helpful on your homework. Okay? What if you had to solve by factoring on this one? X squared plus 7x. Well, it's a binomial, but there's not a minus sign, and you can't take the square root. So difference of squares does not work. However, you can always look for a greatest common factor, and this one has a greatest common factor. It has an x. So I'm going to take out an x, and I'm left with x plus 7. So when I solve, either x equals 0 or x plus 7 equals 0. So my final answer would be x equals 0 and negative 7.